Hello everyone, this is Nilima and today's video is about the valence electrons and the periodic table. What is valence electrons? The electrons in the outermost occupied energy level of an atom is the valence electron. Let us take the example of lithium and aluminium. So this is the model of lithium atom. This is nucleus. And as nucleus contains protons and neutrons, and these are the outermost energy level or the shell in which they contains the electrons. Now in the lithium, the outermost energy level, which is this, it contains only one electron. So the valence electron of the lithium is 1. Total number of proton in lithium are 3 and number of proton is equal to number of electron. So it has 3 electron. The first one contains 2 electrons and the outermost shell contain 1. So the valence electron of lithium is 1. The configuration of these electrons in the shell will discuss in coming video, how they are arranged in the shell and how to write the configuration for them. Now take the example of this aluminium. Aluminium atomic number is 13. So the number of it is the nucleus of the aluminium, which contains neutrons and protons. Number of protons are 13, and in the outermost shell of the aluminium there are 3 electrons, 1, 2 and 3. So the valence electrons of aluminium is 3. These valence electrons are important since these are the electrons which take part during the chemical reaction, and the arrangement of the electrons in the outermost occupied energy level will determine the properties of elements. Atoms in the same group in the periodic table have the same number of electrons in their outer energy level. Means the atoms which are in the same group have the same number of valence electrons. For example, this is the group number 1, which contains hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. They all have the valence electrons equal to 1. This is group number 2, where the valence electrons in all the elements are equal to 2. Beryllium, magnesium, they all have 2 electrons in their outermost energy shell or energy level. This is the 18th group, and these are the group of noble gases. They are the non-reactive gases. Except helium, which has the valence electron of 2. All the gases in this group have valence electron of 8. Their outermost energy level contains 8 electrons. During chemical reaction, one atom can join with another atom by gaining, losing or sharing valence electrons. Means the electrons which are at their outermost energy level, they can gain the electron or lose that electron or share these electrons with the other atom. Now the group number 18th is the noble gases, or the group of noble gases. Except the helium, whose valence electrons are 2, all other gases have valence electrons of 8. They are non-reactive. Means they do not react with other atoms. because their outermost energy level has the maximum number of electrons. Means the outermost energy level of the gases have the valence electrons of 8 and they are fully occupied. So neither they lose electron, neither they gain electron, neither they share electron with the other atom. If you look at group number 17th, although they are non-metal, but they are highly reactive. Since the number of valence electrons in this group is equal to 7. So they need 1 electron to occupy their outer energy level. So they react. Also, if you see the group number 1, they are metals, they are highly reactive, number of electrons in their valence in their outermost shell are 1. So they are highly reactive metals. Reactivity and atomic size. The distance from the center of the nucleus to the outermost electrons is the size of the atom. As you go down in a group in a periodic table, you can see that the elements have valence electrons that occupy higher and higher energy levels. Means as you go down, the energy level, the higher energy level, the distance from the nucleus increases as you go down in a group. And as you go across the group, you can see the atomic size increases from right to left. Means the atoms here have the greater atomic size than the atom which are here. The farther the valence electrons from the nucleus, it is easily lost and therefore the element is more reactive. Let's take the example of sodium and potassium. Both have valence electron of 1. Okay, so both have valence electrons 1. But sodium has valence electron in the 3rd energy level. And potassium has valence electron in the 4th energy level. So the distance from the nucleus to the valence electron in potassium is higher than the sodium. That's why potassium is more reactive. It is easy for potassium to lose electron. So potassium is more reactive than sodium. So reactivity also depends on the size of the atom. How far the valence electrons are from the nucleus, the more easily they can lost or gain they can lost, and therefore the more lost the electron, and therefore the more reactive the element is. That's all for today's video. I hope you like my videos. Please like, subscribe and watch my videos. Thank you.